Hey guys, everyone, it's Adam, one of the co-founders at Revyl, and we're joined with Juan Marcano today, software engineer at Uber. Um, I guess to start off with, Juan, tell us a little bit more about yourself, how you got into software engineering.
Yeah. So, well, everybody, thank you for joining us and listening. If that's what you're doing, I thought it was called Revel, not Reveal. But anyways, uh, see, I got into software engineering like, oh my God, like a very long time ago, over a decade ago. I knew I didn't want to be a doctor or a dentist. I didn't want to be a historian. Like, there was a lot of things that I didn't want to be. So it was kind of by elimination. And honestly, back then, because of the 28 sorry, the 2008 2009 financial crisis, software engineering wasn't that hot anymore, let alone machine learning. But that's what I ended up enjoying in 2012. Uh, I got my hands on OpenCV, and I also started to train my own computer vision models, and that's how I got hooked.
And do you have any I guess a lot of people we know are trying to get into machine learning. Do you have any recommendations for people who are trying to get into or just getting into machine learning, how they should approach learning it or stuff like that?
Yeah, yeah, and my advice would be similar to anybody trying to find their passion. Just try lots of different projects, um, and see what sticks, see what you like. There is a lot of open source stuff right now, lots of guides, tutorials that you can follow. Uh, I don't have a preferred one, but there's a lot of really good ones in deep learning.ai. They're recorded with like very high quality materials, stuff like that, done by lots of companies, even universities and stuff. So yeah, I would say people can start with those and then just build stuff in their free time.
Yeah, that makes sense, 100%. And that's kind of like I feel like I learned it that way as well. Just was like a little bit passionate about machine learning and then started making like random projects just out of curiosity. And
In my case, uh, I ended up working as a research assistant at a lab, and the random projects were paid for. So I
oh, that's
I got a
good.
small stipend to do things that were not so random. They were guided, mostly guided, but they were to solve real problems and tackle difficult things.
Yeah. And I guess we met on one of those projects. I guess somewhat
Right.
similar to like the Dragoncrawl project in 2022. I guess tell us more about how that was and like what was the reason for creating Dragoncrawl?
Yeah. So this goes back to 2019, way before we met. Uh, I when I was interviewing with Uber and a few other companies, I met the guy who eventually became my director. Uh, he said, Juan, at Uber, this is how we do testing, scripts and manual stuff, and that doesn't scale. All the tests have to be executed by machines. The machines have to look at the screens and think on their feet and execute the test. Shouldn't be done by humans, shouldn't be maintained by humans. And then when I started at Uber, I saw what was happening on the ground, and I was like, oh yeah, this guy, his name is Homayun. This guy's
He's
brilliant.
the
This
goat.
is, yeah, this is the GOAT. He's at AMD now. I was like, yeah, this is how it has to be done.
Yeah.
There is no other way. And well, that's how it all started, like from a conversation. And then we partnered with third-party companies. Didn't work out. We started to build our own thing in-house with other teams, but they quit the first sign of failure. And but I kept on going with my team, and then eventually uh, we got you, Gustavo Zoela, and that made all the difference.
That was a super fun, I guess, couple of
Yeah,
internships. Those were crazy. I guess for some context to the audience, what was Uber doing initially for end-to-end testing?
yeah. For end-to-end testing, we used to do two things. One was manual, so we would pay somebody. Actually, it wasn't just somebody; it was a large group of people to do tests. They were in a in a building, they had shifts. We had people testing 24/7 manually, which was very expensive, and we couldn't really cover everything. It was just we would cover as many things that we could cover with our budget. That was it. And then and in addition to that, we were testing with frameworks like Appium, XUI test, and whatever else. And those were effective, but then they required a lot of maintenance. It was too much maintenance, 30 to 40% of people's time. And then in some later documents, some people even claimed 50%. So when you take that 50% of time spent on maintenance, and when you look at the number of employees we have, that is millions of dollars per year, tens of thousands of the bill per hour spent just to maintain.
Do you know how many people were approximately were doing this manual testing, just like going through the screens and tapping?
I have no idea. I never went. I Homoyun did go, and he saw multiple floors of people.
That's crazy. It's crazy
Yeah,
to think that there's just like multiple floors, like complete floors of people just going through, clicking the app, seeing if it works.
exactly. And it wasn't enough.
Yeah, and it wasn't enough. And then these, you mentioned the maintenance on these scripts. What was the main reason that like you had to spend all this time maintaining these scripts?
Yeah, the reason for that is that the Uber apps constantly change. We have, um, well, right now we have like 4,000 backend engineers, maybe 1,000 mobile engineers, and also a bunch of machine learning engineers. And we're all doing things that, one way or the other, change the layout of the app, change the text that's shown in the app, change the colors, the identifiers of the buttons. Everything changes. And because scripts do not move with the changes, they're always just look for one or two things. And if they don't see the things that they're looking for, they just break. And
Oh, I
again, not
see.
because there's a bug, not because there's a bug, but simply because there's a change.
Yeah, yeah. There's always so annoying when you have to like, there's like slight change and then it just completely breaks the whole test. You get no signal
Exactly.
and you get nothing.
And that
I
was the
guess
other thing. Like we had people like debug and triage with their eyes. And we also used to spend like thousands of hours just on triaging these failures, which were most of the time not real failures.
yeah, I get yeah. Yeah. And then people just stop trusting the tests, and
Yeah,
once you lose the trust, it's impossible to gain it back. And I guess segueing into Dragoncrawl, how did Dragoncrawl fix these problems that like you have floors of people doing manual tests, all these tests are breaking, engineers are spending all this time maintaining these test cases. Where did I guess Dragoncrawl come in to fix that?
yeah. So what we did with Dragoncrawl was we used LLMs to look at the textual representation of the screen. And then, well, so we did a few things like we parsed those representations of the screen. That's like, well, that's part of the secret we cannot talk about. Uh, but yeah, so we parsed the textual representations of the screen. So we took the things that were actually actionable, like the different buttons and the actions that you could take on those. And then we would combine those with the goals of the test and then turn them into prompts. And so you would have something like, oh, the goal is to request a trip. And here is what you have on the screen. Button number one, request trip. Button number two, uh, go back. Button number three, close the app. Blah, 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 right?
Yeah.
And then Dragoncrawl would look at that, would look at the options, would look at the goals of the test, and then would say, oh, semantically, the most reasonable thing we should do is to touch the confirm button. And boom, that works. And that's how we did for the test execution. And then uh, that took the pass rate from whatever it was, from something unreliable, like breaking every other day, to passing 99.9%. I don't know, 10.3% of the time. So failing only like 1 out of 300 times, something
Yeah,
like
so
that.
you really got more signal like with all those
Exactly.
passing. Is it was really super signal and kind of testing like a human would. If obviously if we went to the Uber app, there's a slight change, we would know that hey, we can still know how to order a ride. So it's kind of
Exactly.
that similar paradigm.
We wouldn't care.
Yeah, and
And
presumably this was very useful for localization and like different languages as well.
exactly. Yeah, I can tell you about it. So the thing with localization is that Uber works in like 60 different languages and who knows how many cities. And Uber, believe it or not, is pretty much a different product in every city. And so the layout changes on like signing up changes, onboarding changes, like a lot of things change based on jurisdiction. So the whole layout changes. And we used to have, for example, one script to test the app in San Francisco in English, one to test the app in Portuguese in Sao Paulo, one for something. So it was like 10 scripts just for the same thing. But with
Yeah, and then
Dragoncrawl,
the
exactly,
permutations kind of blow up in terms of
exactly.
number.
And it was beyond also in addition to the permutations, like imagine maintaining all of that stuff, which was what people were doing. We're like, oh no, no, we shouldn't be doing this. And then the localization team started to use Dragonfall, and it was just like, hey, we configure a test, and it works in all of these languages in all of these cities. It's fantastic.
That's a huge unlock because then you're also able to see all these permutations that you just aren't able to test before. Like the cardinality was just too high for
Exactly.
manual testing, I imagine.
Yeah.
And now you're actually able to have signal.
Able to have signal and able to know if Uber works in all of these different places. And
Yeah.
the funny thing is that right now, something in over the past like year and a half or so, uh, the the rate limiting factor, the bounding factor is compute. Of course, we don't want to get enough compute to run 1,000 tests per minute.
Yeah.
That would be too expensive. Um, so so yeah, we have a number in dollars, which translates into number of machines, and that is what tells us how many tests we can run.
Yeah.
We're not bound
I'd
by development.
Yeah, which is definitely a huge rate limiting thing for like if an engineer wants to ship, they want to ship. Like you don't want to be rate limited on product development.
Exactly.
One thing we're seeing at Revyl, we're seeing across different companies is they want to use these AI tools, um, but they're unsure of what the bottom line impact is going to be on both developer metrics and I guess out business outcomes. Uh, in Dragoncrawl, what was kind of the impact on both of these things, both in developer productivity and in bottom line income generating
Yeah.
effect?
So so it's a testing system, so it doesn't generate revenue. What it does is because it prevents big outages, it reduces revenue leakage. So because we're like data obsessed here, we pretty much have a number in dollars for how much money we lose, how much revenue is lost when certain types of bugs come out. So there are, for example, like I don't know, like the award is not translated in I don't know in Slovakian. Okay, well we know that I don't know maybe we lose $100. That's not that big of a deal. But we know that if the app crashes and it's a global thing, if it happens for X number of hours, we know in millions how much it is because it's happened in the past, and we have recorded how much we lost. And even without adjusting for inflation, we know that some of these destructive bugs cost in in terms of revenue millions of dollars. So as we prevented those, we were like, oh, we just prevented this. And if you look at that document, that people from finance, people from data science, all of these people agreed on. That exact same thing 2 years ago, 3 years ago was 2.5 million. Okay, we prevented it.
Wow.
We prevented 10 of those, 20 of those, whatever. Okay, these are our savings. And that is as far as revenue leakage that was prevented. And also, of course, this has an impact on brand, which is really hard to quantify.
Yeah.
Uh, but but whatever that impact is, that negative impact is, we prevented it. And in terms of developer velocity, we have an estimate of how much in the past someone would take to create a test in Appium or any of these frameworks, and how much it would take to do that in 50 cities. So that number multiplied by 50, pretty much. And so we are claiming that as part of the impact. And the impact is large, but it pales in comparison to the defects prevented.
Yeah, I get the defects prevented seems huge. I mean, just those 10p zero bugs is around $20 million in, or $25 million in revenue. So just with those, you already see a huge return on investment in creating this testing system, and that's even outside of the possible, like if Uber's not working, you're gonna go to Lyft because you need the drive, you need the ride. It's like a very inelastic thing. So the brand trust that you gain from that is also huge, I imagine.
Yeah. And again, I don't know, the latest number is not 10. It was 10 in 2024. Right now it's much bigger because we've
Yeah.
expanded coverage, we've done a lot more things. So a lot more.
I guess one thing that we see a lot of companies struggle with is they'll have some AI tool that they want to use. It'll work good for the prototype or the proof of concept, but when productionizing it, they have trouble with either finding value, finding how the value is created. Um, I guess creating Dragoncrawl, do you have any learnings regarding productionizing these AI systems, which can be quite complex sometimes?
So here's a bit of good news and bad news for companies. The good news is that it is possible to uh, set KPI, and it is possible for you to find a KPI that if it improves, the impact increases. Now, here's the sort of bad news. Usually, uh, the people that are best fit to choose those KPIs and take action on how to improve them are machine learning engineers. So, people who have been doing machine learning since, since before ChatGPT became famous. And people with this kind of background, you don't traditionally find them in testing teams. So people at Uber used to tell me that I was a bit of the odd duck here, or well, nobody ever called me the black sheep, but yeah, I was pretty much the only person that wasn't a traditional software engineer. Actually, I didn't even
Yes.
study CS. Uh, I studied electrical engineering, and then in my PhD, which I dropped out of, it was just math and math and math and machine learning.
Yeah, I guess it's that intersection of skills is very difficult to find.
Exactly.
Um,
But
yeah, that makes sense. And I guess what are you up to these days? I know you're working on some like computer stuff, computer use stuff now. Tell us more about that.
man, I lost you for a second or a minute. I'm in the office and the Wi-Fi is not great here, believe it or not. But yes, what are
There.
we up to these days? And I think yes, things have shifted a little bit from the last time we talked. Uh, One of the things that we are doing is we're working on computer using agents to well to execute actions for the Uber employees, actions that are very repetitive that end up taking. If you look at the full spectrum of all of the things, they end up taking a lot of people's time. And we have applied this to sales, and salespeople, similar uh, to engineers. They were spending 40% of their time on things not related to sales. uh, well, now, okay, it's not from 40 to zero, but now it's maybe like 15%, 20%.
Yeah.
And
Wow.
we have to keep on, eliminating those other things. Uh, so yes, computer using agents, also like more traditional agents like summarizing text and stuff like that. But now something that we saw that kind of inspired us was the MetaMate by Meta, of course. And the
What is
MetaMate,
the metabait?
yeah. So the MetaMate is an agent that has access to a lot of different agents at Meta, and
I see.
at Meta they use it almost like a coworker. So people talk to it through like a ChatGPT interface, and then boom, it creates data pipelines for them. It productionizes them with the highest level of quality. It um it does uh it helps them with their PRs. It helps them with pretty much anything, and they save millions of engineering hours per year.
Wow.
And that's just on the engineering side. The MetaMaid is also used by non-engineers for other things. But of course, there are just at least the metrics that they have disclosed is related to engineering. And we want to do something like that here, uh, making we want to make an omni agent. That's what I started to do. Uh, and at first, it's just going to look like a regular agent that orchestrates and supervises a lot of smaller agents. But long term, this is going to look like a world model. And I think this is where a lot of enterprises are going to go, world models. Because right now, LLMs, VLMs, uh, they predict a lot of things based on semantic similarity, based on what they see, but they don't really understand cause and effect. So for the
Yeah.
people in the developer productivity space, the LLM right now cannot tell you what happened as a code change propagates through the system. Why? Because the LLMs were not trained for this.
Yeah.
They're trained for next word prediction and for a few other things, but no, uh, something we're not gonna do it this year. Probably, maybe at the point. Oh, of course, this year is almost over. Maybe we're not gonna get to it next year, but we're gonna go towards world model because yeah,
So do you
we
think
really want that cosmic
like
effect.
the do you think the diffusion architecture will be a lot more prevalent based on this like world model hypothesis? Because I imagine um, diffusion models are much better at parallel tasks. This seems like a perfect use case for these diffusion models.
Uh, it could, but I think what's gonna happen is eventually uh, we're gonna graduate from LLM and VLM. They have an inherent flaw that prevents them from becoming role models and learning cause and effect. There's people in robotics uh, that they use LLMs and VLMs for part of their role model, but it's not just LLM VLM. And I think, and who knows, maybe we discover something better than LLMs. Well, Jan LeCun, there's a
Yeah,
rumor
Jan
that
LeCun
he's gonna
hates
leave.
LLMs.
I agree with him that yeah, we they the trip is almost over. So we gotta get on the next boat.
So do you
But yeah,
think these world models will be created by some new architecture that's more suited for these cause and effect type analysis? Is
I think might as well. Yeah, I think the if a lot of people have grasped that there are huge opportunities in world models, lots of business models around functioning world models. So might as well take one of those and take one of those business models, business cases, and solve it with a world model, and then expand to others.
Yeah, that makes sense. I guess some people do think that LLMs have some intrinsic world model because they gain this emergent reasoning from like training on a long time. But I mean, it does seem like to an extent that reasoning capability has plateaued. I mean, we're not seeing
Yeah,
model releases as often. You're seeing like open source Chinese models come up to the benchmarks of closed frontier models. It does seem like we are reaching some form of plateau or at least mini plateau. So that makes sense.
and there are companies out there that already moved away from LLMs. They created their own architectures, and they can reach 170 million tokens in context,
Oh wow.
and
Do you know
those are
what architecture they're using, or is it?
it's a proprietary one. They call it long-term memory.
Ah, wow.
And there's other ones that created other ones. Was I actually don't know how they made the building blocks. Um, but yeah, there's people moving away and getting this crazy context windows, and as a result, in addition to pretty good results. So yeah,
Yeah.
you know
So I guess
the
going
signals are out there.
yeah, I guess going back to the computer use agent, you mentioned sales as an aspect of repetitive work being automated. Is there a cluster of areas where you see this repetitive work being the most valuable? Like for sales, I can think of like maybe prospecting with clay or like outbound is very repetitive and something that would be apt for this. Do you see? I guess are there patterns to where you're seeing this being the most valuable? Because a lot of people
Yeah,
do want to automate a lot of stuff, but I guess it's hard to know where the value is. I mean, we see a lot of people doing like outbound BDR, but it just doesn't work that well because I feel like people feel like you need a personal touch for that BDR. AI copy is not that good.
yeah,
Do you see any pattern around where it's most valuable and most useful?
yeah. So specifically in sales, uh, everything related to lead management, regardless whether you have a computer using agent or just an LLM, super valuable over there. Uh, then of course having LLM or VLM or CUI, whatever, update the CRM for you uh, without you having to do it, super valuable. And LLMs looking uh, at past conversations, at the outcomes, trying to associate selling points to outcomes. That is also a huge one. Like trying to understand the personality of the counterpart. That is also a really big one. And so that is just for sales. But then like there's also legal, right? Like understanding contracts, and because that gets pretty expensive. And immigration. Well, Uber hires immigration companies to do immigration for us, but there are startups out there that are filing immigration stuff for people just using LLMs,
Yeah, there's a lot.
and they're very successful because it's a lot of very repetitive, very manual stuff. Uh, uh, in finance, like data reconciliation. There was a time when my wife uh, used to spend maybe like a full week or two just doing data reconciliation. This was years ago, um, and it got better, but then it still required a good amount of manual effort. Now you could automate like 99% of it, maybe even more. So like the well, I agree with Tom Altman. He said that the the cost of the things that you do manually on your computer are gonna go down in value because now you have all of these things. And yeah, I agree. Uh, I think all of the systems are just gonna push us to just do the 1% to 1 to I don't know 10% things that will be really hard for a machine to do confidently.
I see. So like the vast majority of things that are very easy to automate will probably face these deflationary pressures because inference costs are
Exactly.
decreasing and it's much easier to do. And then that tail end of activities that are very hard to do, maybe need more of a personal touch, hard to automate,
Exactly.
you think will have, I guess, power law outcomes in that they'll be a lot more useful and a lot more valuable, economically viable.
Exactly.
I guess. I guess then people should spend their time getting better at those. I guess
Oh
that's
yes. Get better at those. Get better at I don't know also welding because it's gonna be really hard
yeah.
for an LLM to become a welder. Uh, and uh, and also like get really good at using the tool because what happened in the industrial revolution was that the people that didn't want to change their ways, those were the ones that suffered. But the ones that adapted, learned how to fix the machine, how to operate the machine, how to build around the machine, those were the ones uh, that saw growth, stability, all of that.
Yeah. I guess. I mean, I get this question a lot from like my younger cousins. Um, if you were because there's so much changing with AI, if you were to give someone advice on what they should do in terms of education or in terms of, I guess, learning about AI, what would be the biggest recommendation? I know we touched on this earlier with regards to getting into machine learning, but what would the general answer be?
Yeah. So in general, first of all, put joy first. Don't study uh, CS just because. Let's start with that. So put joy first. Study what you like, and try to do or try to go for the path that you think you would love, even if you're wrong. And then try a lot of different things with AI and without AI, and then let your passion find you. And try to bring AI into all of your projects. Unless it is welding, because I don't think I don't think we have AIs for that right now, or
Yeah,
or plumbing. I think I think yeah we don't want to use AI for any of those things yet. Um, but besides a handful of professions and trades, try to bring AI and maximize for joy and learning opportunities, and then passion's gonna find.
yeah, that makes sense. If you really
Sounds
enjoy
very
the process,
formulaic.
it'll be easy to continue.
Exactly.
Yeah, I guess just closing out here, Juan, I just wanted to say, like during our internship, that was the most fun time. It was so good. I really appreciated that internship and like working
Yeah,
on
man, we were
Dragoncrawl with
all
you.
maximizing for joy. That's why.
Yeah, yeah,
Yeah,
that
man, it
was
was a
super
lot of
fun.
fun with
Like I
you
couldn't
and the other
imagine
guys.
like yeah, like going into an internship, being able to just like I guess like most internships are just you have like some small ticket and then you just do those tickets. But this was like got to work on a full product, for full like project from inception to productionizing it, and it was super fun and learned so
Yeah,
much.
well, that's usually that's how it is with me. I don't throw softballs.
True, true. So sometimes you gotta go up to plate against
Exactly.
Shohei, you know?
Exactly. You gotta throw the hard ball, the curve, and that's how you build your strength.
Yeah, that's true. No strength without adversity.
Exactly. No pain, no gain.
No pain, no gain. Exactly. Yeah, yeah, yeah. Awesome. Thank you for taking time out of your busy day to come on.
Thank you. And yeah, we'll keep chatting. Now it looks like I have a meeting, so I'm gonna go.
All right. Take care.
You too. Good to see you.
Good to see you.